Welcome to the video on solving and graphing compound inequalities. If you see an equation like this, where the x term or the variable is in the middle, this means that 4 is less than or equal to x plus 2, and also x plus 2 is less than or equal to 8. So the term in the middle, the x plus 2, is both greater than or equal to 4, and also less than or equal to 8. As you take a look at that, I want to get that x by itself. So I'm going to subtract 2. Well, if I subtract 2 from that term, I have to do that from every, and when I do that, I get 2 is less than or equal to, and the plus 2 and the minus 2 cancel, so I just have x is less than or equal to 6. So if I have my number line, here would be 2 and 3 and 4 and 5 and 6. So I know that x is greater than or equal to 2, or 2 is less than or equal to x. When something is equal to, it includes the solution of 2. So it's going to be a solid circle, which indicates that 2 is greater than or equal to 2. All the other numbers that are greater than or equal to 2 are over there. The second part of the compound inequality is x is less than or equal to 6. Well, 6 is less than or equal to 6, so it's a solid circle with an arrow to the left. Now, the final solution, since it is and, whenever you see the term in the middle, it implies and. Both have to be true. X plus 2 is greater than or equal to 4. X plus 2 is less than or equal to 8. So now I go to my blue and my red line and take a look and say, all right, all the numbers from 2 to 6, both parts of the equation. So my final solution is what I have graphed in green. 2 plus 2 would be 4. 4 is greater than or equal to 4. 4 is less than or equal to 8. If I substitute the upper extreme, which is 6, 6 plus 2 would give me an 8 in the middle. 4 is less than or equal to 8. 8 is less than or equal to 8. But if I were to go smaller than 2 or numbers larger than 6, it would solve one part of the compound inequality, but it wouldn't satisfy the other part of it. Second question, take a moment, try this. First step is I'm trying to get the x by itself. Once again, this implies and. Negative 5 is less than or equal to 2x plus 3. 2x plus 3 is less than 9. Well, first step is subtract 3. If I do it there, subtract 3, subtract 3. And I end up with negative 8 is less than or equal to 2x. Those two cancel, is less than 6. The opposite of multiply by 2 in the middle there is divide by 2. Divide everything by 2, and I end up with negative 4 is greater than or equal to x is less than 3. So on this one, I'm going to put negative 4. I'll put negative 2, 0, 2, 4. So the first part of this, if I look at the middle part, negative 4 is less than or equal to x. Well, I'm going to take a look at this part of the equation and say negative 4 is less than or equal to negative 4. Negative 4 is less than or equal to negative 3. Negative 4 is less than or equal to negative 2. So all of these values from negative 4, including negative 4, and larger, satisfy what I have up here in the red. If I look at the second part of the equation, which I'll circle here in tan, x is less than 3. Well, the numbers that are less than 3, is 3 less than 3? No, it's not. So we have an open circle at the 3. Now, is 2 and 99 100ths? Is 2 and 999 1,000ths less than 3? Yes, it is. All of the numbers that are just smaller than 3 would satisfy that part of the equation. Since we have an and, we're looking at the values that satisfy both the yellow graph and the tan graph. And the numbers that are included in both graphs would be from -4, including -4, because this point is included in both of them, all the way up to 3, but not including 3 because the tan circle is open. So the ones that fit both would be graphed right there in blue. Next question, x is less than 2 or x is greater than 6. Well, here's 2, here's 4, here's 6. X is less than 2. The numbers that are less than 2, 2 is not less than 2. So it's an open circle. 1 and 99/100 is less than 2. All of those work. If I go to the other side, x is greater than 6. 6 is not greater than 6, but 6.00000001 would be greater than 6. This time, I have 4. It needs to solve either one of those two. Well, what I have up there right now is what would work to solve either one of those two. Numbers that are less than 2, not including 2. Numbers that are greater than 6, not including 6. A question you may have is, well, what if that word in the middle were and? Well, then I'm going to look at the two graphs and I have to go, which numbers are included in both solutions? Numbers that are less than 2 and numbers that are greater than 6. And the answer is there is nothing that is included in both. So my solution, if the term in the middle were and, would be an empty set. However, this one, it is or, so it would be what I had done initially in light blue. Last one is very, very similar to what we just did. X is less than or equal to 2, or x is greater than or equal to 6. It's a 2, it's a 4, it's a 6. Once again, numbers that are less than or equal to 2, 2, but this time it is a closed circle because 2 is equal to 2. If I go to the second part of that, x is greater than or equal to 6, well, 6 is equal to 6, so that works. It's going to be all of those right there. If it is or, what I have graphed in green would satisfy the or. If I switch it and I had the term and, numbers that are less than or equal to 2 or greater than 6, and there is no number that we have that is less than or equal to 2 and greater than or equal to 6. So if the term in the middle were and, it would be an empty set. Hopefully that helps on the beginning of graphing, solving and graphing compound inequalities.